No, no one's turned up yet. What time is it? 5:30. Anyway, we'll see how we go. We got one there, beauty. That'll do. This is a follow-up from the last video on this detector that was half fixed, and then it decided it wanted to half work and all the rest of it. It was one of the scenarios that I did mention before, that the where I'd taken out those high voltage MOSFETs on the input stage, the ones that block the flyback. Things had gotten past those before and had taken out BF908, the small low voltage MOSFET P-channel device, and also took out BAV99. So obviously one of those old MOSFETs must have gone short circuit and killed things. So anyway, I've just pulled the old bits out, which are these dead bugs here. I've lowered this camera down a bit too, so maybe you can see a bit better. First of all, I'm going to put the BF908 in circuit, which goes there. So I don't think it's taken out the op amp. I checked it and it seemed okay. Okay. It's a drain. Source. And I've got to do gate 1 and gate 2 on that, which to get in there to do it. A bit of solder. So the dual gate MOSFET is in. I've put the low level device in there. And now I'm going to put in this BAV99. Just a dual diode, signal diode, high speed, sort of. So in goes the signal diode. Give them a touch up with a bit of fresh solder. It's got a bit of a ball on the end of this solder now. I'll just chop that off, because I want a fair bit of resin to come out to make it all nice and clean. So that's there. Okay, it's okay. Okay. Okay, we are in. Now it's on a double D coil in cancel mode. Let's move all this stuff, put some non-conductive material there for it to rest on. Hopefully it should fire up and work. It's a bit noisy and we're in cancel mode. We'll see what's going on. Okay, it looks okay on the oscilloscope. And so does that. Okay, let's flick this into out of cancel into it's more noisy in cancel mode. It's very interesting. Something is not right then, is it? Okay. By the looks of it, that that op amp there is acting as a pass device with, it looks like it's got no signal amplification, because the waveform's perfect, but there's nothing there. No one's home. So what I'll do, this is the only way to fix this properly, is get rid of the double D coil. We've got to get rid of the double D coil because we want to have a look at both inputs from a common source. We don't want the double D thing where we haven't got high voltage on one side, we have on the other, and you are looking at very low level signals. You want to see it exactly as it is. So I could use a cancel coil, which will be a lot better than, I've got to use a real mono type cancel coil. I can't use ones I make because they're not correct, but here's one here. Okay, that'll do the trick because that's a cancel coil, but it's a mono. It's just a flip phase coil. So this will give a better indication on exactly what is happening. See, the thing is, at the front end of these things, the slightest thing, and you're talking nanovolts, and it's very hard to get in on the nanovolt scale. So what we've done, we'll flick him into, it's funny, isn't it? We've got normal, which is double D. E for enhanced is actually mono on these. So we'll stick it into E for mono. That's the old designation, how they did it, just to confuse everybody. So we'll turn him on and we'll have a look and just see what it's doing. There it goes, it's fired up. Okay. Yeah, the waveform's different. There's still something a little bit wrong on the high voltage, well, basically the channel that connects to the transmit coil if you're using a double D. Yep, there's no amplification happening. It's only switching waveforms. I was going to zoom. I don't know if you can even see this, but I've got to go, oops, wrong way. There's basically no amplification whatsoever. And I can see it there. The waveforms are not rounded or anything, which you would expect. But if I was going to do the metal touchy on the input. So basically, if I have this on the output, let's have a look. Yep. I think that op amp got cooked. It's functionally functioning like it's acting as a switch, but it's really weird. There's no amplification on it. Yeah, it's acting as a like it's interesting because I'm touching the input. Things are happening, but make sure that I've got all this connected up properly. Make sure that is definitely off. Give it a spray of isopropyl. That's the thing with these detectors. Once anything on the input stage blows up, it's a chain of events all the way down. And where it stops is you just don't know. Yep. Just making sure everything's connected up properly and we don't have any short circuits. There shouldn't be because it would be really skewed if it was. I don't know if you can actually see. Oh, probably a bit hard to look at this and look at that at the same time, but there's something strange going on. Now, on the here, I'll better discharge that nasty piece of work. The capacitor here. Come on. It let out a few whimpery cracks, so obviously it was partially discharged as well, so that's all right. Now, have a good look here. I'll leave the coil in, doesn't make any difference because it's a mono. Okay, better turn that on. Okay, 0.771. 0.771. So the input MOSFETs, the high voltage ones, are okay. After I swapped them out, they are switching. Otherwise, the waveform then the other end will be absolutely all over the shop. Let's make sure. Just going to check these feedback resistors. That's right. They're okay. So I would say that's okay, that's okay. Now, just want to get on the coil wire here, the red one. Yep, so we got input. And I'll just check the BAV 99. There's BAV 99 diodes all over these things. Check there, just to make sure that we haven't got shorts or open on these diodes here. sometimes they can play up. Okay, clean up the tip so I can get on there. Okay, so it's 0.78, it's fine. We change the polarity around because there's 2 diodes in the package. It should read the same. .78, and this one should be okay. This is the low voltage side of things. Normally, if you go DD, but at the moment we're on high volts. Yep, 0.78. Swap them around. Just make sure that these are still okay. Okay. 0.9, fine. For some reason, I think that was shorted. It's allowed high voltage to come through and take out the op amp. So it looks like I've got to put another op amp in it. I really should have checked that first. I didn't. It's my own fault. I did have some spare op amps sitting here. I don't think I'll put in an IR4475. No, that won't work. I've never found those op amps I had here that just disappeared. They're not on the floor, nowhere to be seen. So where they went, I don't know. Very strange. Anyway. Get another one. I'll leave them in the package, and I'll take this other one off the board. We've shorted him out, so he's got no residual current. Nothing's going to do anything crazy. We hope. To get this out, I'm not going to use hot air. I'm just going to blob it each side and heat it and flick it out. That's simple. Clean up the connections a bit. So we have this op amp out of circuit. Okay. And sit over there. Do its thing. Okay. I think I can just put him straight in. We'll see if this is a problem. Okay. That looks pretty good to me. Now I'm going to fire him up. Or it. Fire it up. Whatever. And we'll just see what happens. Because there isn't enough parts there anymore that anything's faulty. Because they're all new. Anyway, turn it on. That sounds a lot better. Even though it's on that big cancel coil, there's a lot of noise in here at the moment. And these things have always been noisy. Well, I'll just find the earth point here. You got to remember all the earth points on these have white paint over them. Oh, there we go. So the op amp was cooked. And we've got identical waveforms on both channels now. It is a GP Extreme. They are a bit noisy, but we can fix that because these have the magic button, of course. We can give it a bit of a rough tune. We'll see if it comes up working okay. I bet that makes noise too. I'll turn that off. So there you go. That was multi-faults in this detector. Unbelievable. We'll get there eventually. Okay. I might have to just do a little bit of fine tuning up, but it sounds okay. Biggest trick is we'll see if it ground balances with the hot rock. I'll make sure I'm in tracking. Else it'll be wasting my time, won't I? Okay, it's in there. We'll put it in the tracking. Okay, it's working. But listen how noisy the GP Extreme is. I think I might know why. I've got a switch mode power supply plugged in over here, and I think it can be noisy. Hang on. It takes a while to discharge. No, it wasn't that. What about this one here? Turn that off. Nope. Just one of those. It's a fairly big coil, fairly big, flip phase coil, or a cancel coil, whatever you want to call it. But it's working. Okay. But these are very, very sensitive, even though we're on normal, everything's normal on it. I was going to get a tiny target here and just do a test on it. I'm going to find one of the tiny ones. But yeah, that's a GP Extreme. You can make them quieter than that. Well, that's all right. Yeah, I'm just touching 0.0025 on the coil winding. That's working. I'll give it a test with a 0.5 gram. It gets that 0.1 gram. Okay, so we've brought this back from the land of the dead to the land of the living. So thank God for that. All we're going to do now is get rid of these jumper wires and put in a proper capacitor, not a big yellow monolithic. You want something which is a bit better than that, like a NPO type capacitor there, but I'll check the oscillator anyway, make sure it's all right. So this repair on this detector, first of all, the oscillator wasn't oscillating. So I swapped out this chip here, the 74HC04, and we replaced it with a 40106. I've had to fix some tracks that were cut here. One of the heads of a through plate via disappeared. I had to go through it and redo that. So that's basically the output of one stage into a 4053 here. This is the other stage, goes into the junction of two resistors, 2.2 Ks. They go into the 4053, get switched around for your different modes, for your cancel, double D or mono. That's controlled off the switch. Later models are controlled off the micro. So, well, it could be actually, some of it could be controlled off the switch and micro on this one. I have to check out. You just got to follow the switch wires. It might be micro controlled on this. They might, well, the micro just might hold the lines up on the 5 volt supplying, and the switch crashes them down through 10K resistors. I have to revisit. I can't remember all these detectors off the top of my head. Too complicated. And okay, so the BF908 was turning brown on the board. That was here somewhere, which has probably disappeared as well. Put these lights back on. And that one. Yeah, so that was the, I don't know if you can see that. That was the input transistor. That was brown. That was going brown and died. It goes like, it's like cooking toast. It slowly goes brown. So that's dead. And I think that's a BAV 99 went brown as well. So that was toast. And yeah, the other bit should be around here somewhere, but probably flicked off because they're so small. Definitely don't want that sitting there. Yeah. Just having a look around. So yeah, redo this. Replace 2 op amps. I cooked another one, so I had to replace it again because I should have replaced that that transistor there. Sorry, I call them transistors out. They're actually MOSFETs, and I didn't use the what were they? BSS 84s or whatever they are, or that. I actually put better devices in there. And can I ever see them? Where are they? Might be here. What are they? I'll tell you what I put in there. RSM 002 P03. Better device. So that is what is in there. So yeah, BF908, BAV99, BSS84 or better is in there. Turn him around. Put in that one there, BC857. It doesn't actually do switching. Well, it does, but it doesn't work in the way you think it does. The ADG 333 directly drives the gates of these two here. Both gates connected together, of course. I won't go into that. And there's a 100 ohm resistor somewhere on the board. And what actually happens is that there's a the transistor here, because it's a P channel. What it does is when you take away its bias, it basically turns on. So it goes short drain source, and it's there to try and get rid of the capacitance, the internal capacitance on the gate of these FETs, and drain it off faster. That is what it's for. The on time is still exactly the same, but it tries to dissipated off faster. I think that might be for a faster receive turn on, because there might be some residual capacitance there, which is holding the MOSFETs on slightly, and that could degrade the receive signal. But as you can hear these things, they're really, really, they sound noisy. You can get rid of the noise. There's capacitors here, but if there's 4 of them, you can, I think, actually not those ceramic, this, monolithics I'm touching, but on the wires here, I think they're 18 nanofarad. You can change them to 36 nanofarad, and that makes it a bit quieter. You can also quieten it down by adding a little bit of capacitance to the audio amplifier, which is something really simple. It's basically a quad op amp is the audio amp in these, and there's lots of little things you can do. Oh, it could be a TLO. Is it a TLO 61, 62? Off the top of my head, I'm just trying to remember. I haven't delved into the componentry part of these for months and months. I just don't recall what's what in the zoo. But yeah, on these, yeah, there's your audio. You got a lot of filters here. You can muck around with the audio and the filters. There's some mixing that goes on down here, and there's your audio wires there. Yeah, there's a filter block here. There's meant to be a jumper on here where you can adjust the tonal quality of what you like, I suppose. And like I say, the whole thing is coated in thick white paint, and it makes it very difficult to work on. So anyway, it's fixed. All it needs is a clean and tidy up, and yeah, that's what it is. But she's a little bit on the noisy side, and I'll investigate why that is. I could do extra filtering on it. You could do many things on these to make them behave a bit better. But it is what it is. It's more or less the first edition of the modified upgraded detectors. You compare that to the board of a GPX, all done one board. That's, yeah, Mohammed, don't worry, I'm doing your detector. I was going to get some of these things out the way first. But yeah, this thing here is 2 boards and absolutely loaded with parts, and they got it down to that. And you have a look at the newer ones, there's less parts again. So anyway, I thought I'd just finish off that video on this repair. I sat down and just watched a bit of lefties losing it and that sort of stuff because of Trump trashed the Democrats over in the US. I think it's quite funny, them all blowing steam out their ears and carrying on like idiots. But that is that. So hopefully, if you want to fix up your own detectors, it does give you some insight onto some of the common things that do go wrong with these. You could I could write something out. You could get a lot of test points here for various waveforms and supply and switching and whatever, but that's very pedestrian. Most of the faults don't usually happen in these areas. You won't get a divider go down and stop putting out 1 division ratio or something. The whole thing will fail, or it'll just work. Things like drive you bonkers. Any of these things here in the integration part of it go haywire. That'll drive you bonkers because the detector will be looking like it's working fine, but it won't ground balance and stuff like that, and you'll just pull your hair out. The rest of it's just basically power supply, supervision, circuitry, looking after the damping high, the high voltage leveling off. just general timings and stuff. You got a rudimentary analog digital converter there. So I think it's a 10-bit. It's got a micro on it, but you know, the micro, it's more or less housekeeping. It doesn't do any of the waveform generations, all in here. You know, you do have control for things like auto tune and stuff like that, but different modes is basically just selecting supply control lines on this EEPROM here, or EEPROM, whatever they put in there, or flash ROM, whatever. So it's pretty basic stuff, you know. We don't have inductors that big there. Well, you can do, but that's around about 10 microhenry. There's a lot smaller ones there that are less susceptible to noise pickup. So you can put a surface mount one there. Just make sure it's not a slug. Make sure it's a high Q type inductor, not something that's used for smoothing power rails. If the Q isn't right, it won't work. It just won't oscillate. So that's why they've done these on toroids until they were able to probably get small ones. I don't know. But, you know, this sort of thing, you look at the early detectors, the 21s and 22s, had this sort of big, chunky ferrite wound thing in there. But like I say, you can get them as, you know, as small as that or smaller. They'll work fine. Just depends on what they are you're getting. Just make sure they're like RF rated type inductors, not DC smoothing types, because it works on a different principle. They'll use very lossy ferrites, where you don't want lossy ferrites in this. You want something that is not lossy at all. So there you go. That's the device done. Now I've got to, instead of doing these live things, I've got to do a proper video after this. I've got some stuff I should do a show and tell on. So I will do that, and I'll close this one down. Like I say, I haven't looked at any comments because it's all facing away from me. I don't know what's going on. So if there is any there, oh yeah, someone said, yeah, it's work. Oh, there we go. Hang on. Oh, there's a heap of comments there. Thanks, Woody. It's Kamal. Ben. Try turning the off. What? Oh. Yeah, I've got half the menus over the writing. It's hard to read. The battery, I've had these problems down before. Yeah, these things, when they blow up, if it blows up the high voltage part of it, well, should I say the input stage, high voltage blocking part of it, and it goes short circuit, takes everything out. It just goes straight down and goes cook, 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 till everything burns out. So it's something you got to watch out for. Yeah, there we go. Yeah, take your time. Someone says it's a GPX 2200. No, it's just a GP Extreme. This is. There's no such thing as a GPX 2200. Might be a GP, but not a GPX. So anyway, one done. I just I don't like the amount of overall noise. I'm going to just make sure that nothing else weirdo was done to this detector. You know, like we say, fiddle fingers, you know, causes a lot of trouble, and more trouble than what you really want to know about. Because you do one thing on these. Like, I had one come in once, and every IC, all the small ones, basically, no, I think just about every IC, all the CMOS stuff was all burnt in the middle. And I couldn't work out what the hell they'd done. They'd bypassed the input switch circuit, which limits, like if you put too much volts in, it won't turn on. And also if there's a fault draws too much current, it normally won't turn on either. It's also an under voltage lockout. So they shorted that out so it would work, but then they put the power wires on the wrong way around, and the I don't know how much current they shoved into it, but the protection diode was burnt in half as well. And they're rated at 3 amps. So they shoved power into it backwards, and it went through, and everything on the standard battery rail, yeah, it cooked everything. Every chip had a brown burn mark in the middle of it. So that by the way did not get repaired. I said, no way, no, that's too much, especially digging through all the white paint, and anything can go wrong. If you heat a chip up, you think it's going to pop off, and it grabs the bloody circuit tracks and solder's not properly melted, and you pull it up and you lose tracks. On pulling out 25 odd ICs, you're asking for trouble. That's just, you're a glutton for punishment if you want to try and repair stuff like that. You'll spend a lot of time doing it. You may end up with a complete failure, and then you don't know where it is or how to, and pull everything off and try and find it again. It's not really worthwhile doing that. So that's my thoughts on that. But yeah, that's that. Anyway, I'm going to turn this thing off, the camera I mean, and yeah, that's how you basically fix up the input stage of the detector. Anyway, the last part of it was, except I think one of those I think the other MOSFETs there must have been in failure mode, and it cooked the input when I got the thing going. Damn it! It cost me a op amp. It'll cost the customer an op amp anyway. Anyway, all good. Catch us later. Where's the off button? Up there. See yous.